So before the break, we talk about how to integrate into dimensions. And what we just did before the break, we did how to do double integration. Double integration. So I told you that when you do double integration, you have to look at the domain you integrate with respect to. So case number one, if you work with rectangle domain or rectangular domain here, So that means the region that you want to integrate with respect to is just a triangle, or not a triangle, so a rectangle, sorry, a rectangle here. Well, so it's easy for you to integrate with respect to this area because if you know that x is from A to B and y is from C to D, for example, well, your integration going to be integrate your function f(x,y) and then dx x from A to B and dy from C to D, right? That is how you integrate on the rectangular domain. A, B, C, D are just numbers, so easy to integrate. Well, if you want to integrate dy first, so you can do that too. It's going to be y from C to D first, and then integrate x from A to B after. Well, that is what we just did for the basic one. Well, and after that, I give you an idea how to do case number two, which is going to be the general domain. In case of general domain, you need to pick the order of integration first. You have two ways to do it. You can pick dx dy or dy dx. Well, it depends on the picture or the domain that you want to integrate with respect to. Sometimes it's going to be easier to do the x dy. Sometimes it is going to be easier to do dy dx. For example, if you have something like this parabola, for example, the red one, and then you have another parabola, let's say the green one here, something like that, and then you want to integrate double integration here over the region R. This is the region R that you have. For example, it's going to be this one, let's say. Well, if you want to integrate with respect to this area, so what is the easiest way to do that? The first thing that you have to think is you have to pick the order of integration. Would you pick the x dy or dy dx? So, well, if you remember from before the break, I told you that you have to look at the region first. And if you want to pick dx dy, it means you have to integrate with respect to x first. This thing gonna be the same as you draw a horizontal line to the picture, and then you're trying to do the cut by using the horizontal line. But if you use dy dx, this means you're gonna do something like a vertical line. So it means you do the cut like vertically. Well, the best thing is that, well, if you look at this picture, you can see that, well, this region, it is best to do dy dx, right? Because if you do the horizontal cut, if you do the vertical cut, so you can see that every time when you integrate, you're gonna go from the red curve to the green curve all the time. And that would make the world a lot easier for you because you can start from, well, let's pick dy dx, and the order of integration gonna be y from the red curve to y to the green curve on the top. And then suppose that this is the point x equal to a, y equal a and y1. This is the point b and y2. Then you're going to integrate the outside from a to b. So the boundary on the outside, it's going to be the range of the x value that you integrate with respect to. Does it make sense? Well, that is how you set up the integration. Well, the same thing with the case that you're gonna pick the x dy, because sometimes you're gonna see the let's say the same picture, but you get something like that, and let's suppose that I wanna integrate with respect to the pink area here. So you can see that the best way to do it is just you draw the horizontal line, which means you're gonna integrate. The best thing is you integrate dx dy of the function fxy here, and then you're gonna again integrate from the purple curve to the black curve, right? Because it's gonna be left to right. This is the black one. This is the purple one. And then for the outside boundary here, so you have to look at what are the values of y that you integrate with respect to. So suppose that this is the point x1 and d, or x2 and d. This is the point x1 and c. For example, you're going to integrate from c to d, something like that. So it is critical for you to set up the integration, because this is what I want to test you on the final exam and on the quiz and everything. So I want you to set up the integration correctly. You need to learn how to do this. But step after the setup, that one is going to be the calculus 1 technique. Because once you set it up, the integration is going to be, some calculation from calculus 1, which is not, our focus for this class. Our focus is we trying to test you how to set up double integration. Okay. Oh, we're gonna have, I think about 4 to 5 examples for today. Well, I think we have about 25 students now, which is good. All right, let's start by example 47. Well, let's do it together. So I know that some of you had a very, very good break. So you forgot everything already. So I'm trying to go slow this time, to recall you what we just did before the break. All right, so example 47 here. Well, let's start by looking at this question. Well, the question asks us to sketch the region of integration. Well, first of all, you need to sketch the region of integration. And then they ask you to switch the order of integration. So what you have here, it's the integration in the order dy dx. Well, they ask you to switch it to fxy dx dy. Well, your task is you have to switch this thing to the x dy. Well, some of you are gonna say, Ajahn, why don't we just do 0 to 1 here and 0 to 2x here? Can we do that? Just switch, the outside and inside boundary? The answer is no. You cannot do that because, well, you can do that only if when, the domain is a rectangle, which is going to be the case that you have all constant on the boundary here. Well, if you see that your numbers on the boundary here, 4 numbers that I highlight in pink, they are all numbers, you're good to go. You can switch the order of integration. Let's suppose that it is 0 to 2 and 0 to 1. Well, then yes, you can switch it. But here, in order to switch here, you can see that the problem is you have 2x here. This is not just a constant. Well, that means you have to sketch the region first, and then you switch the order of integration after. Well, I will show you how to sketch the region here. So first of all, when you have this, so I'm gonna say that, well, I'm gonna let my D, this is my domain. It's gonna be set of all x, y, such that, well, because the thing that I have in the box over there, it's mean y is going to be between 0 and 2x. And I have x is between 0 and 1. Don't you see that? Well, I have y here between 0 to 2x, and I have x here between 0 and 1. And from that, you're trying to get the picture from there. So in order to get the picture from there, so, well, you have to draw the graph, y equal to 0, y equal to 2x, x equal to 0, and x equal to 1. And you try to get the region D from there. So I'm going to show you here. Well, this is the y-axis and x-axis. Well, I'm going to draw the graph, y equal to 0 first. Y equal to 0 is what? Y equal to 0 is just the x-axis, right? Well, that's my first one. So I'm going to do, hey, this is the lead curve for me. Y equal to 0. All right. The next curve is going to be y equal to 2x. How can I draw y equal to 2x? Well, this is going to be just a line, right? So I'm going to draw here, y equal to 2x. Well, this is just a line. Well, maybe make it more, add more slope. So it just 2x, no. So let's say this one, y equal to 2x. It's just the, the rough sketch. And then after that, I have, well, let's use the green one now. So x equal to 0. Well, x equal to 0 is this. Okay, good. It's just the y-axis, and then x equal to 1. Well, let's use the orange one here. That is, well, my scale is not proper, but you can imagine this is x equal to 1. And then once you get all the line here and all the picture here, so you think what is going to be your region D? Well, from the picture here, I can guess that, hey, Ajahn, my region D must be this one. Would you agree? Yeah, because you have the line over there, and the region that the line, intersect. Well, the line gonna intersect, and then you're gonna get the region. And the region that we have is the yellow one. If you are not sure you get the correct one or not, you can double check with the question. So the question say you're gonna integrate dy dx. That means you integrate dy dx. That means y is inside. So that means you're gonna draw a vertical line, right? Because you integrate with respect to y first. So that means basically you do the vertical line here for the the given integrals. So you're gonna start from, hey, I integrate y from 0 to y equal to 2x. You can see that, hey, every time when I draw a vertical line, I start from the red curve, which is y equal to 0, to the black curve, which is y equal to 2x. Makes sense? Good. And then x from 0 to 1. That means I start from x equal to 0 to x equal to 1. Hey, yes, that's correct, because this is the region that I integrate with respect to from 0 to 1. Well, your task is, hey, Ajahn, my task is I want to do integrate fxy dx dy. Basically, it means you have to switch the direction from vertical line here. Let's switch the world. You're gonna do a horizontal line. And then your integration boundary gonna be different. So here we're gonna start from, well, if you draw a vertical line, a horizontal line here, sorry, a horizontal line here, you can see that every time you start from the black curve and you end up with the orange curve, well, in your head, you should think that you're gonna start from the black curve, and then at the end, you're gonna get the orange curve. Does it make sense? Because you have that. Here, every time you draw a horizontal line, you get that. And what is your boundary of integration here? It means what is the range that you draw a horizontal line? So you can see, oh, I want to know what is the range here, so I can put it in here and here. For sure, this is going to, well, you have to find an intersection point. When x equal to 1, here you're going to get the intersection point y, x equal to 1, y equal to 2, right? Because that is the cut, the intersection between x equal to 1 and y equal to 2x. Well, so now you know that, oh, we got it already. So that means y start from 0, and at the end, we have y equal to 2. So that means on the outside, you're going to get 0 to 2. And then how do I say what is the black curve? The black curve is actually x equal to y over 2. right? Because y equal to 2x, this is the same thing with x equal to y over 2. Well, this is dx first, so you have to start from dx, which is x equal to y over 2, and then to the orange one, which is x equal to 1. Good. And that is the answer. Do you think you can do this one? This is going to be the same question as the final exam. 6 point. Well, if you can do it, for sure you get 6 point on the final exam, because this is the essential thing that you need to know how to do it in calculus 2. You have to switch the order of integration. Well, we have one more example for you to practice together here. Well, let's do that. Well, any questions so far, everyone? Sounds good. You feel the the idea of integration just come back to you, right? All right, let's do example 48 here together. Well, I have a question. Let's see. I have a question from student Salataya. She asked us, can I write the integration start from 1 and go to y over 2? The answer is no. Well, if student answer 0 to 2 outside and 1 to y over 2 inside here, no, this is going to be wrong, not correct. Because when you do the x first, you have to start from the bottom curve to the top curve. This is going to be your bottom curve. Sorry, not bottom curve. This is the left curve, because you go by horizontal line. This is the right curve. Well, remember the order must be left to right or bottom to top. You cannot switch it, because if you do that, well, the answer after you integrate, it's going to be different, because you're going to get the negative side, because it's going to be, it is not correct, because your answer going to miss the correct one by negative side. So that's good question though. Thank you. Nida said dy dx. Okay, that was from the first few minutes, so that's good. All right, let's do one more. Well, okay, if you feel like, hey, Ajahn, I feel like I understand it, but I want to practice, well, let's do this one. Let's do example 48. This is the question that, well, pretty similar to the previous one, but this time I asked you to switch the order from the x dy to the y dx. All right, so let's do that. How can we do it? Well, for sure, you can see that you have y square here, so that's no way that you're going to switch it immediately. You have to draw a picture. That is what I mean by the first week that we met, and then I told you that, hey, the integration is not hard. The hardest part is, can you draw a picture? Well, if you can draw a picture, everything is going to be easy. All right, here we're gonna look at our domain first. Well, D stand for domain here. This is my domain for, well, it is a region that I want to integrate with respect to. It's going to be all the point x, y, such that this time x is between 0 and y square, and y is between 0 to 2. All right, not hard. Well, we're going to draw a picture first. So let's see here. We have y-axis and x-axis here. X equal to 0 is simple. It's gonna be x equal to 0. It is the y-axis. Huh? All right, just keep in mind that this is x equal to 0. And then another one I have x equal to y square. How do I draw x equal to y square? Well, actually gonna be parabola, right? But that one, this is x equal to y square. All right, that is x equal to 0. Well, x equal to y square, this is the same thing as y equal to x square, but the axis is going to be different, but the graph going to be parabola anyway. But it's just open to the right, it's not open up. And then after that, you have, let's say the orange one, y equal to 0, which is this. Well, the idea is you're trying to draw everything, and then you just get try to figure out what is d at the end. And then the last one, I'm going to use red, y equal to 2. Okay, let's say this is y equal to 2 then. All right, so what is going to be your region? So, well, you look for the one that you get the region from, after you draw the line, and then you look for the region you have from the intersection. Well, which is going to be the one that I highlight in green. Does it make sense? Well, you cannot pick the one that I highlight in orange, in yellow here, because that's no boundary. This is not good as well. This is not good as well. So, well, you see pretty clear that you're gonna use the green one over there, and then, well, as I told you, if you are not sure, you can double check with the question. The question say, hey, when you do the x first, when you do integrate by using the horizontal line, you're gonna integrate x from 0 to y squared, which is good. Well, you can see x equal to 0 is the green curve, x equal to y squared is the blue curve. Well, you go this way all the time. However, the question say, hey, we're gonna switch to dy dx. So let's do that. All right, so I'll give you a minute. Well, answer me in the chat. What is going to be your inner boundary here? Y from where to where? All right, so give me in the chat y from where to where here. Well, this is going to be your check-in for today. I keep a record now because, well, for those of you who check in every day after today, you're gonna get at least 90% for the quiz. But, well, let's think what is going to be your, well, I asked you here, the question mark here. Well, if I want to integrate dy first, so what is going to be your boundary here? All right. Now it is debatable between 0 to 2 or root x to 2. All right. What do you think? 0 to 2 or root x to 2? Well, we seem like we have to group now. Natakiat and Sarataya say root x to 2, but, well, Dong Cook, right? He said root x to 2 too. Well, you can see that this is the inner integration. So, well, do not trust your friend if you feel like, hey, I'm gonna just do the majority. Maybe it is not correct. Well, trust yourself. Root x to 2 or 0 to 2. What do you think? All right. Well, I think it's about 20 students answer now. So good. All right, so let's look at the answer. So for those of you who answer 0 to 2 and square root x to 2, let's think together. So I'm gonna just zoom in here. So what I want is I want to integrate dy dx. Well, that means I have to draw a vertical line, right? Because I'm gonna integrate with respect to y first. Well, you can see every time I draw the horizontal, the vertical line, I start from this curve. See that? The blue curve first, and then I hit the red curve at the end. Blue to red, blue to red, blue to red, blue to red, blue to red. Well, that means here must be blue curve. This must be the red curve. What is the blue curve here? X equal to y squared. However, you have dy. So you have to change this thing to y equal to square root x. And that is going to be square root x here in the lower bound of the integrals. And then on the top, you're going to hit the red curve over there. Hit the red curve. You see that? And the red curve is y equal to 2. So that is y equal to 2. Sounds good. So for those of you who answer square root x to 2 correct, you're good. For those of you who answer 0 to 2, that means you miss the picture here. Well, if you feel like you're going to answer 0 to 2, it's going to be here to here. This is 0 to 2, which is not what we want, because we want only the area that we shade in green. Does it make sense? Well, it is good to make a mistake here, because you learn a lot, and you will not make a mistake again on the exam. Does it make sense? Well, this is the area of learning, so you can make a mistake here, which is good. I appreciate that. And then now x is going to be from well, from where to where, you're going to start from here. So x is going to be 0 to, you need to find this intersection, right? So x equal to 2, y equal to, oh, no, what x? Well, let's look at this thing again. X equal to 4, y equal to 2, right? Okay, because, you know, y equal to 2, it is a cut the intersection between y equal to 2 and x equal to y square. So that means when y equal to 2, x equal to 4. Good, thank you. Who answered me in the chat? Nida, right? Nida and Shutri, yeah, x equal to 4. And that means you're going to integrate the outside from 0 to 4. Because this is the thing that you here, you just integrate with respect to, you know, the x value that you draw a vertical line from 0 to 4. Sounds good? Well, you can see this is not that terrible. The question looks hard, but it is not terrible if you can draw a picture and you understand the picture. Sounds good? All right, we have a few more examples. I think we have about 20 minutes left. Well, we can do more. I think 2 or 3 more. All right, keep going. Any question, anyone? Any questions so far? Good. So you see the idea, right? All right, next example 49. All right, so I want you to integrate sine y over y dy from 0 to, from x to pi, and then you integrate the outside going to be x from 0 to pi. Here you can see that, well, when I ask you to integrate this, well, some of you are going to try integrate the inner thing first. So, well, that is what you should do anyway. Well, when you have the question asks you to evaluate something, so, well, for sure we have to evaluate the inner function here. However, how do you integrate sine y over y dy? You don't have a formula for that, right? You know that you can integrate sine y dy. Yes, you know how to integrate this. You get negative cosine y plus c, right? But when you have sine y over y, how would you do that? Well, I think someone said by part in the chat. Well, some of you say by part, but you know, if you try integration by part, it is not going to be a good way to do it, because by part gonna make this one more complicated. Well, the way that we're gonna do here is we're gonna switch the order of integration. Well, if you can switch the order of integration, you put x inside here. Well, you hope that if you switch the order of integration, well, you can integrate easily now, because if you switch the order of integration, sine y over y going to be constant, right? And once sine y over y is going to be constant, you can pull out of the integration. It's going to be, and then you just integrate the x first. Whatever you get here, you hope that you're going to make a cancellation with y, and then you can integrate it. Well, this is the question that will ask you. Actually, they ask you to switch the order of integration. Well, for some of you who never seen this thing before, you're gonna spend your time trying to integrate sine y over y, which is going to be terrible, because sine y over y is not a function that you can integrate easily by hand. So what you should do is you're gonna switch the order of integration. So gonna note it here. We will switch the order of integration. All right, let's do it. So we're going to switch the order of integration. Well, first of all, I need to draw the domain, right? This is, again, from compared to the previous question, this is x, y from x to pi, and x from 0 to pi, all right? What is going to be the picture here? So let's look at the graph. First of all, I have y equal to x, which is this line. This is from y equal to x here, right? And then next y equal to pi here, which is whoa, green one. Okay, here y equal to pi. All right. Well, I have it in section here. It's just pi and pi already, which is good. And then this is x equal to 0, y equal to pi. Okay, just add intersection so it's easy now. And then, well, the next part is x from 0 to pi. X equal to 0 is this line, x equal to 0. And then x equal to pi is this one. Well, anyway, what is going to be region D here? Well, if you can see from the picture, or my guess is going to be this one, because now it looks like we have the blue curve, the green curve, and the red curve. Well, they made it. Well, we get the triangle from these three curves, right? Well, this is going to be our graph y equal to x. Well, I did draw it. Oops. And then here, the graph here that I have, this is x equal to 0. All right, looks like we already got everything we want. Good. So we're gonna switch the order of integration. So let's do it. So we have integrate 0 to pi x to pi sine y over y dy dx. So I'm gonna switch to dx dy sine y over y. So x gonna be from where to where? Again, if you wanna integrate dy dx, dy dx mean you draw a vertical line. Dx dy mean you draw a horizontal line. So you're gonna switch from the vertical line that you have. Well, this is the question. The questions here, they do the vertical line. So they do y equal to x to y equal to pi, and then x from 0 to pi. Well, what we're trying to do is we are going to do the horizontal cut. Well, which means we're gonna do from the red one. You can see that red to blue, 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 red to blue. Well, the red one is going to be x equal to 0. This is the red one. The blue one is x equal to y. X equal to y. Make sense? Well, when you look at the solution, it's pretty simple, but you have to understand how did I get 0 and y here? Well, the reason is I get, red to blue, red to blue, red to blue. Here, this is why I get 0 to 1. And then the boundary that I have, what is the range of y that I integrate with respect to? It's going to be 0 to pi. All right, 0 to pi. Well, after you switch the order of integration, you can see now, yeah, it's so easy because we can pull out sine y over y, and then you integrate that. And then here, the inside thing, so I can integrate now sine y over y. Well, I integrate dx, I get x, right? And then I evaluate x equal to y, x equal to 0, dy. And that is integrate 0 to pi sine y over y. That thing is y minus 0, and then dy. And then you can see, oh, good, I have a cut now. So I have a cancellation y and y. And that is integrate sine y dy from 0 to pi, which I get, okay, negative cosine y, and then y from 0 to pi, which is negative cosine pi plus cosine 0, which is negative 1 plus 1, which is 2. All right, so the rest of the work, this is just the integration from calculus 1. Well, this is from cal 1, which I assume everyone can do it. But on the test or on the quiz, on everything, I will focus to the part that you need to set up the integration. The part that you calculate here, this is not going to be a big deal because that is from cal 1. Everyone can do it, but well, you expect to learn how to set up the double integral. That is the point. Make sense? Good. All right, and I hope you feel better about double integration now. What do you feel like, Ajahn, I cannot follow anything? Well, that is a problem now because this is the the important thing that you need to know. All right, so I think we can do, well, 2 more and then we're done, huh? Maybe 1 more. Let's look at the time. All right, so we have example 50 here. We have integrate 0 to 1, integrate y to 1 of that function 1 over x to the fourth power dx dy. Well, similar to the previous question, if you want to integrate dx first, I have no formula for 1 over 1 plus x to the fourth power. All you know is, here, this is arctan, right, from count 1. But anyway, if it is x to the fourth power, no clue how to do it. Well, let's switch the order of integration here. So we're going to switch the order of integration. So what I want is, I want to switch it to dy dx, because I can pull out x, 1 over x to the 1 plus x to the fourth power. And then after that, I can, after I pull out, so I can integrate with respect to y, and that is going to be a lot easier. Well, similar to the previous question, that means you need the area. Okay, let's move that a little bit. So this is x and y, such that and that y equals x, y from 0 to 1. Okay, good. Well, my handwriting is not that nice. Okay, and y from 0 to 1. Good. All right, now we draw a picture again. So, well, for the picture, well, I will tell you here. For the picture, the thing that you need to review is a line, a parabola. This is what I'm going to ask you. You need to be able to draw the line. Parabola, yes. Absolute, yes. Other than that, no. Well, you do not need to be worried about, am I going to ask you to draw y equal to x to the fifth power or something? No. Well, the graph that you're going to see for this class or on the exam anyway, it's going to be just line or parabola or absolute value or something like that. Well, it's going to be the easy one that you can draw it. So here we have y equal to x. Okay, y equal to x here. All right, that. And x equal to 1 is over there. This is x equal to 1. This is y equal to x. And this is y equal to 0. All right. And y equal to 1 is over there, well, which is the cutting point, 1, 1, something. Good. Well, the area is going to be the green one here. We got it. The area is going to be the green one. Makes sense? And then after that, we gonna switch the order of integration. Well, before we do the horizontal line, right? Because we start from x first. Now this time we're gonna do the vertical line here. Well, which means we're gonna start from y equal to 0 to y equal to x, and then x is gonna be 0 to 1. Simple like that. And then you integrate everything here. Integrate 0 to 1, 1 over x to the fourth power, and then integrate 0 to x of dy dx here. Well, when you integrate dy from 0 to x, you're gonna get x, right? So at the end, you're gonna have x over 1 plus x to the fourth power dx. Well, this thing now you can integrate it because you have x on the top here. Well, you can just use substitution. So we're gonna let u to be x squared, and then du by dx gonna be 2x, and that means dx equal to du over 2x, right? And then you integrate 0 to 1, x over 1 plus x to the fourth power dx. This is going to be integrate x over 1 plus u square, right? Because x to the fourth power, this is x square, so this is u square. And then dx going to be du over 2x. All right, this cancel out. And then this is going to be integrate 1/2 integrate 1 plus 1 over 1 plus u square du. Well, keep in mind, this is x from 0 to 1, x from 0 to 1, x from 0 to 1. Well, I switched to the u already, but at the end, when we plug in, we're gonna plug in x from 0 to 1. And this is 1 over 2, integrate that, you get arctan. u, and then x equal to 0, 1, x equal to 0 here, and that is arctan u is x squared, so it is 1 square, and then minus arctan 0 square. Good. Makes sense? And then that will be your answer. Oh, okay. Some of you say, where did arctan come from? Well, this is the formula from Cal1. Integrate 1 over 1 plus x squared dx. This is arctan x. Well, but you know, if you have this question on the quiz or on the exam, the formula will be given. No worries, no worry. This is the formula how to integrate that. Well, this is just, you know, how to integrate 1 over 1 plus x squared dx. This is arctan. Arctan 1, this is pi over arctan 1. Okay, let's what is arctan 1? So arctan 1 is what is the angle that you're going to get 1 when you take tan. So you know that tan pi over 4 is 1, right? So that means arctan 1 is pi over 4. And tan 0 is 0, so that means arctan 0 is 0. Well, this answer is pi over 8. All right, well, nice. Sounds good. This question, well, it looks terrible when you integrate because you it used the technique from Cal1, huh? Well, but this is a simple technique. I don't know how you appreciate Cal1 when you learn it, but you know, this is the technique of integration. But the part that we add for Cal2 is to switch the order of integration, so you can see that it's easy to integrate. Sounds good. All right, anything else? All right, we're gonna do one more question, and then that will be the last one for today. And then on Wednesday, we're gonna pick up the last example, and then we're gonna move to polar coordinates. All right, so let's do example 51 together. This is the last one for today. All right, keep in mind that we're still working on how to switch the x dy to dy dx. This is going to be, you know, one learning objective that you need to get from this class. All right, so we're gonna they ask you to switch the order of integration. Well, for sure, you have to sketch the region first. Oh, this question is a little bit harder compared to the previous one because the graph that you have look like it's a circle. Everyone know how to draw a circle, right? Well, this is the circle x squared. Well, when you have x squared plus y squared equal to a squared, this is the circle. This circle with radius a. Well, I don't know about pre-calculus, but you know, I don't know about your background. So some of you are gonna, you know, forgot everything, even how to draw a circle. But keep in mind, if you see this equation, this is just a circle with radius a. All right, so we're gonna look at the first x, y here. So we're gonna do the same thing, x from 4y over 3 and wow, square root 25 minus y squared, and also y from 0 to 3. All right, so let's think about the equation first. So we have x equal to 4 over 3y, right? We have x equal to square root 25 minus y squared. We have y equal to 0 and we have y equal to 3. This is what we need to put it in the same graph. So x equal to 4 over 3y, this is the same thing with y equal to 3 over 4x. This is actually the line with slope 3 over 4, right? This is x squared equal to 25 minus y squared. This is x squared plus y squared equal to 25. This is actually the circle with radius 5. Y equal to 0, this is the y equal to 0, this is just the x-axis. And this is just the vertical line. All right, so let's draw everything into the same graph. All right, this is X, this is Y. All right, we're gonna start from the circle. So circle with radius 5. Well, the reason why I just look at the, the first quadrant, you will see it in a minute. Well, actually we have a circle with radius 5, but actually I zoom in quadrant number 1, because at the end we're gonna have y equal to 0 and y equal to 3 here. Well, because the radius is 5, so y equal to 3 is gonna be just here, right? This is just y equal to 3. Whoa. If you want the scale to be more perfect, well, but this is just a rough sketch, so y equal to 3. And then after that, I have the line slope 3/4 here. Well, when you draw a line y equal to 3/4x, it's gonna be the line that passed the origin, and this you have slope 3/4. Well, you can see that when x equal to, well, let's see again. When y equal to 3, x equal to 4, does it make sense? For this line, you have y equal to 3/4x. You can see that when y equal to 3, you can see that x equal to 4, right? Because if y equal to 3, you plug in back to the equation, so you're gonna get x equal to 4, which actually means this point is actually x equal to 4, y equal to 3. Well, the scale is not proper because I don't use a ruler. I just sketch it. This is 4 and 3. So this is going to be your line. The line y equal to 3/4x. Make sense? Well, if you have a graph paper or something, when you draw it, if your scale is proper, you're gonna see the picture clearly. But for this one, you can see that I just make an approximation of the picture here. And once you get the picture here, you have the line already, the circle already, and everything is ready now. So what is going to be the region D? You need from x from the line to the circle. X gonna go from the line to the circle, from the line to the circle. This is when you do integrate dx first. So this is when you do the horizontal line. You're gonna go from the line to the circle. So that looks like you're gonna go from the line to the circle when you do the horizontal line. Look like the region gonna be this one, because it's gonna be line to circle, line to circle, line to circle, line to circle, right? And does it make sense if you do that, line to circle here? Yes. And your region of integration gonna be, well, the range of the y values gonna be 0 to 3. Well, good. That means you find it. Yeah, this is going to be the area that you integrate with respect to. Well, this question is not easy because the picture confuse you a little bit, because some of you are so weak in geometry, so you will take your time to draw a picture and analyze the picture first. Well, you have enough time for sure on the on the exam or on the quiz. Well, for sure you draw a picture first, and then once you get the picture here, you figure out the region here, and then after that we're going to set up the integration. So, well, we're going to go quick here because we don't have much time, 7 minutes left. Well, I'm going to give you the answer immediately, but on Wednesday, we're going to pick up the answer again if you don't understand it. So the answer for this question, if I want to switch the order of integration to dy dx, well, you can see that the thing that I have to do is I am going to switch my idea to the vertical line. Well, you can see that on the first piece, I start from the x-axis and I draw a vertical line, and it's gonna hit the line on the top. But on the second piece here, when I draw a vertical line, I'm gonna start from the x-axis, and then at the end, I'm gonna hit the circle here. So that means I have to split into two pieces here. So the first thing, the first term, this is number one and number two. So this is actually number one. This is actually number two. So for number one there, so we're gonna start from y equal to 0, which is x-axis, to y equal to 3 over 4x. That the first piece, you can see we start from y equal to 0 to y equal to 3 over 4x. And the next one, we start from y equal to 0 to the circle. So that's mean y equal to 0 and then to the circle, which is y equal to square root 25 minus x squared. Well, you have to, simplify your circle a little bit. And then your x here is 0, 0 here. This is x equal to 4, y equal to 0. This is x equal to 5, y equal to 0. So this is from 0 to 4 and 4 to 5. All right, well, I went a little bit fast because we don't have much time left. But if you do not understand the answer for this question, we're gonna pick up again on Wednesday. Well, that is all for today. All right, thank you everyone. So if you have not checked in for today, put something in the chat, please. Otherwise, you can go. Thank you.